Welcome to IPDay's Webinar Wednesdays. I'm June Rawl, IPDay's Project Director. Thank you for joining us this afternoon. Today's webinar is part one of a series of math webinars designed to provide you with additional support as you implement the newly developed College and Career Readiness Standards for Adult Education. The webinar is facilitated today by our lead IPDay math designer, Ronald Cruz. Ron has a wealth of knowledge in adult education and puts his practices to work in the classroom. Today's focus is to provide you with a follow-up to the face-to-face math ABE workshops that are currently being conducted throughout the state. In addition, we want to draw your attention to the rationale of the Math College and Career Readiness Standards and its implications in the classroom. By the way, if you haven't signed up for a face-to-face math training yet and you want to, it's not too late. Just check the IPDay event calendar and see where there is a location that's close to you. Today we're also going to discuss the three advances or shifts in mathematics: focus, coherence, and rigor. All these shifts are really important as instructional changes and are demanded by the College and Career Readiness Standards that are written specifically for adult education. You know, it really just boils down to the mission that we're all committed to, and that is preparing our students to be one step closer to being college and career ready. Much of our time today will be devoted to the what, the why, and how this can be accomplished. Ron will share with you some student-centered activities that he has found successful, as well as some IPDay support materials that will help you in your curriculum development and implementation. At the end, we'll have some time for questions and comments and go through how to assess the IPDay's e-trainings, and you'll also be able to find relevant materials that are associated with the College and the Career Readiness Standards for ABE Math. I hope you find the webinar informative as you continue to develop a conceptual understanding of these key advances and you pick up some new ways to teach them. Stay tuned for part two of this webinar series. It will be coming to you in the spring. All of these math trainings are aligned with the face-to-face workshops, and they also complement the online e-training that will launch in mid-November. So think of IPDay as your one-stop learning resource center. We're working hard to provide you with new resources and tools, so check the website regularly and please stay connected with us. Remember that all of our webinars are recorded for you so you can review them later or share the link with your colleagues or your staff. So enjoy the webinar. On behalf of all of us, we thank you so much for your continuous support and dedication to the field of adult education. Ron, I'm going to turn it over to you.
Thank you, June. Good afternoon, everyone. Thank you for spending precious time during the day to participate in this webinar series. I know a lot of you have already participated in the face-to-face workshops, and some of you may not have participated in the face-to-face workshop. Don't worry about that, because what we're going to be focusing for today's discussion will be on the rationale and the implications of these newly developed College and Career Readiness Standards for ABE Mathematics. So let's begin our webinar. One of the things, there are several changes that happened with your curriculum. Things have gotten rearranged, things have gotten removed, and things like that. But if we're going to organize the three major changes that happened in your newly developed curriculum standard, is that there are three of them. First is focus. What happened with this first shift is that significant content has been decreased or taken away from your curriculum to allow the teachers to spend a little bit more time teaching the concepts, developing the students' understanding of the concepts, and also give them a little bit more time to practice on the skill. The rationale for focus is focus strongly where the standards focus. So meaning we will have more time now to teach the important math concepts, and along the way we will be able to save some time in the end so that we can do some enrichment and supplemental activities for our students to elevate their knowledge into higher levels of mathematics. Why are we eliminating certain content from the mathematics? Well, based on research, high-performing nations significantly narrow the scope of content so that the students can focus their time and energy. Focusing on too many topics have a negative impact on student performance. If you compare our previous curriculum to our newly developed College and Career Readiness Standards curriculum, you will notice that the topics had significantly decreased because too many topics is just not realistic. First, adult education teachers are working with very limited amount of time to teach these topics. So adding more topics to these topics, concepts, and skills to the curriculum doesn't really help them and really sets the students up for failure because they're not going to be able to cover them. Focusing on what is emphasized in the standard gives students a strong foundation and uses instructional time productively. This is coming from the ACT survey of college faculty. That means that now that we have less topics to teach, now we will have more time to establish a strong foundation and use our instructional time so we can develop those critical thinking activities with our students, further developing and deepening their understanding of mathematical concepts. Identifying concepts that support the major work of each level creates a coherent flow of knowledge and skills within the level. So meaning we're first going to identify the major or the big ideas of mathematics. There are, in our curriculum, there's 10 of them, and we will be covering all 10 of them, and we're going to talk about what those 10 are later on in this webinar. Why? How would focus impact our classroom? Focus means that some content is more important than other content and receives more time and attention. That is true. You know, let's talk about certain content, such as writing equations and solving single-step and two-step equations. If we cover them at a limited amount of time, we really put our students at a disadvantage because those are the skills and the foundations for algebraic thinking in the future, and they will use that skill in their college or career pathway, whichever one they choose. A majority of our students will be moving on to the GED. To the GED classes or GED preparation classes and eventually taking the GED test. So therefore, we must have our students ready and prepared to tackle on these GED subject areas when they move from the ABE classroom. Other content supports the more important content. That is true. That what you're going to see in this curriculum is content is arranged in such a way that the content supports each other and reinforces each other. The standards of mathematical practice becomes a critical focus in the college and career readiness standards and the mathematics curriculum. So that's one thing that you will also see that is inserted and that is new in our curriculum is the mathematical practices, the standards of mathematical practices. And we will cover what those are later on in this webinar. If you have participated in our face-to-face workshop, you may already be familiar with these mathematical practices. But as we go along, we will be covering them in detail. Okay, so this is just an example of how the major focus areas, or when I talk about main ideas, how are they arranged in the different levels of ABE? If you look at here, we have level A, level B, C, D, and E. There are like 5 levels from the foundations where we took out the college and career readiness standards. Level A would most likely would be representative of your foundation level ABE students. Level B would be for your beginning foundation students. Level C would be a combination of your high beginning, low intermediate students. Level D would be your high intermediate students, and level E will be your advanced ABE students. So as you can see, in the area or in this major shift of focus, we start off with students as teaching them whole numbers, and then we build upon the concept of whole numbers, and then we teach them fractions. As they move up to the level and gain more proficiency with whole numbers and fractions, we now started introducing to them at the level C, or in a low intermediate, high beginning levels of your ABE, positive whole numbers, fractions, and decimals. So now we're going to assign a sign, whether it's a positive or a negative, to these numbers and then start working with them. When you go to the level D, that's when you start introducing your rational numbers. Rational numbers are are any number that can be expressed as a fraction, A over B, and that's when students are going to be exposed to operations of the different rational numbers. So we could have a decimal multiplied by a fraction, and students must be able to manipulate their way through or work their way through that operation. And in level E, we have real numbers. So this will encompass all of the real numbers. So this will also include your irrational numbers, which is pi. And also level E, or at your advanced level, that's when your radicals come into play, which are also part of the real number system. So let's take, for example, the square root of 2. Now, you heard me talk about the different domains. Our college and career readiness standards for ABE mathematics is divided into 10 different domains. We start off with the first domain as number and operations, base 10. So these are all base 10 numbers, 10, 20, 30, 40, 50, and doing some operations with them. Of course, this domain also includes your basic whole numbers. Number 2 is operations and algebraic thinking. Algebraic thinking is built upon or is being implemented in all of the domains, because as you go into domain 5, and 6, number, operations, and fractions, and expression and equations, you will still employ algebraic thinking in that process. Domain number 3 is measurement and data. So this is how we represent, organize, and analyze data, such as a line plot or a histogram. Domain 4 would primarily focus on geometry, so concepts such as areas, length, further subdividing it into or going a little bit deeper into shapes. We talk about the attributes of different shapes, like the angles, the vertices, the sides. And then we go into areas and surface areas and volumes. Those are the things that are going to be tackled in the geometry domain. Moving on to number 5, domain number 5 focuses on number operations, but strictly on fractions. So this is where you're going to have your regular fractions, irregular fractions, or improper fractions. You will also have the conversion between types of fractions, such as a mixed number to an improper fraction. This will also include operations on fractions, multiplication, division of fractions, and things like that. Domain 6 is expressions and equations. So first of all, students need to learn how to write an equation, how to evaluate an expression based on a given number, and then also solving equations such as single-step or two-step equations. Those are the two things that are major in this domain. Number 7 is the number system, and this is when we introduce to the students the concept of irrational numbers. This is also when we lay down all of the numbers into a number line and see how they are, how they compare to each other. So the knowledge of the number system and how each of the numbers behave, such as, let's say, integers, those are all tackled in this domain. Domain number 8 focuses on ratios and proportional relationships. In this one, the heavier focus is how to write a ratio and also how to find a missing or completing a proportion, I'm sorry. And then number 9 would be the main focus of domain 9, statistics and probability. So we will have topics such as simple probabilities, experimental and theoretical probabilities. And then in terms of statistics, can students look at a graphical representation and draw information from it? Or we can also, this where we talk about the mean, the median, and the mode, the measures of central tendency. And then lastly, we talk about functions. So this is when we really go into an equation, let's say an equation of a line, y equals x plus 3. How does that look like? Now, how does that compare to y equals 2x plus 3? And what does the graph look like? How does the table of functions look like? So when we look at and evaluate a function, what does that look like? So those are the things that that are going to be discussed or covered in the domain number 10 on functions. And as you can see, domain number 10 really lays out the strong foundations because this is where the GED teachers will pick up from. The students' prior knowledge of functions is so important so that they can start now working word problems with them when they start with the GED. At the start of their GED classes. Let's talk about the second shift in the standards. The second shift is coherence. Let's take a step back for a minute and think about what does coherence mean. Like for example, you're talking to someone and somebody is expressing himself or herself to you. When you say that that person's expression of what they're saying is coherent, what does that mean? That means that you fully understand how each of the topics that's being said correlates to what he's going to say next. And that's how our curriculum is designed in such a way. The sequence of topics are carefully laid out so that when we teach, as we teach along and we follow the pacing of this curriculum, we are spiraling through the different concepts. So let's take, for example, you get into the part of the curriculum, let's say talking about fractions, and you've discussed and practiced and did some activities with addition of fractions with your students. Now, when you start covering, let's say, algebraic thinking and expression and equations, they may start encountering equations that have fractions in it. Or they may also be asked to evaluate an expression given a fraction value for x. So really, how these content and skills are being laid out and sequenced, it gives the teacher the upper hand in spiraling through the content material. So it automatically forces the teacher and the students to review material that they've covered in the past. So why coherence? Let's talk about that. Well, based on research, coherence allows students to demonstrate new understanding built on foundations from previous studies. So it's really important that we review what we've covered before, because those are the foundations of what we're going to talk about in the future. Coherence prevents standards from being a list of isolated topics. You know, in the past, let's say, I don't know about you, but I remember in the past that we studied geometry in a month, and in that month, that's all we did, is all geometry. And then after that, the month after that, we switched to algebra again, and then we never touched geometry again. That's not how this curriculum is designed. This curriculum is designed in such a way that when you move into algebra, there are going to be problems in algebraic problems that require you to represent your problems in a geometric fashion. And therefore, that's why when we do our face-to-face workshops, and when you come to our face-to-face workshops, you will notice how we've incorporated geometry and algebra together so that they mesh and they fit perfectly in your classroom setting. And we introduce the use of different tools such as manipulatives to further strengthen the alignment and the connection between what you do in geometry as it is to algebra. Lastly, coherence means that each standard is not a new event, but rather an extension of previous learning. And you will see that as we go along, because what I'm going to do is we're going to try to unpack a piece of your standards today and then see how this coherence looks like, you know, and see how it's really impossible for you to cover a topic in isolation. And this curriculum is so coherently designed that as you cover each topic, you will also find yourself covering other topics that you've covered in the past, and you're also laying the foundations for the topics that you will be covering in the future. What are the implications of coherence in your classroom? content now unfolds meaningfully for your students. That's what happens, is that if you kept using the information they've used in the past, they found it relevant, and you find less and less of your students asking you, why do we have to learn this? Connections between concepts are made both within and across the levels. So meaning, if you are in NRS level 2, you will not only tackle content within that NRS level, you will also find yourself incorporating topics in NRS levels 3 and also reviewing NRS levels 1. Excuse me. Students and teachers expect knowledge and skills to build and grow, and that's the only way this can happen, is if their curriculum is coherently designed and it's sequenced in a strategic fashion, so that students can realize as they move forward with the concepts that, hey, I'm using the same concept before, but I'm building upon that same concept and doing more complex things, and I'm able to break down more complex situations or real-world situations to solve problems. And that becomes more automatic with this newly developed college and career readiness standards. Let's look at now the third shift in our standards, which is rigor. And rigor, based on our college and career readiness standards, is a combination, or is a delicate balance between three things. And the three things are conceptual understanding, procedural skill and fluency, and the application. These three things have to be balanced when you're teaching the skills and the concepts to your students. One caveat that a word of caution is that don't try to force all three of these components to be present in any of your lessons. That is quite stressful, I will tell you that for a fact. But what I'm suggesting to the teachers, or I'm suggesting teachers do, is that to try to incorporate one or two of these components of rigor into your lessons. So, for example, let's do multiplying fractions. Let's just take multiplying proper fractions. 1/2 times 1/3, or 2/3 times 4/5, something like that. As you do this procedural skill and practice your students with the procedures and give them more practice so that they become more fluent with the procedures that you've taught them, don't just settle by doing that. What I suggest is that to incorporate the application of it. Why is multiplication of fractions so important? Where do we apply that? So as you talk about that and as you teach these things to your students, start incorporating word problems or real-world situations that incorporate multiplication of fractions. Let's say, for example, you have half of a butter left, or half a bar of butter left, and you will only use 1/3 of that. How would you represent that in an equation or an expression? You know, try to incorporate the real-world application to give some meaning to the procedural skills that you are teaching your students. And then another thing I'm guilty of that as a teacher. When I was a teacher, I didn't focus as much on the conceptual understanding. I just kept telling my students, well, that's how we did it, or that's how I was taught. Take one thing, for example, when we divide fractions. When we divide fractions, we are always taught, well, we have to change the operation to division, to multiplication, and then we have to use the reciprocal or flip the second fraction. And when I was learning and when I was in school, it was never really explained to me that well. I didn't get to the real root of the explanation. I didn't get to understand the real explanation behind that procedure until I got to my calculus class, and that was way in college. So I missed all this time I've missed all of the beauty of math all that time. But anyway, the point is, we wanted to explain the real concept behind the procedures that we're trying to teach the students. Why does this procedure work? If you have certain shortcuts, start asking your students or start discussing with your student why shortcuts work, and teach them that the value of finding out why something works is just as much valuable as the answer. Let's talk about the rationales for rigor. Why? Why do we have to incorporate rigor into our classroom? Surveys of employers and professors of first-year credit-bearing mathematics courses validate the importance of rigor in the instruction. So they notice the absence of rigor. Students that are stepping into college, first year of their college credit mathematics, they notice that there is such a shock in the students because they're not used to that type of rigor before. Let's set our students up for success by mimicking the level of rigor that is being introduced to them or that is being applied to them when they get to collegiate courses. I'm not saying that rigor is not also present in our career and technical courses and vocational courses. There is rigor there too, and therefore students are also shocked when they enter into these fields without experiencing the actual rigor that's supposed to happen inside the classroom. Students with solid conceptual understanding can generalize and apply concepts from several perspectives. So again, it is impossible. I've had some teachers ask me, what is the best GED preparation book that you've had? Like all these practice problems and things like that. And I always tell the teachers there is really nothing you can do to prepare your students for every type of problem that GED can generate or ABE or in the ABE test. It's really impossible for you to do that, nor do you have the time to do that with your students. What you can do to make your students more successful is to solidify and strengthen their foundations of the concepts so that when they are faced with a unfamiliar situation, they can always fall back to the concept and figure out their way through a particular problem. Students who can perform calculations with speed and accuracy or fluency are able to access more complex concepts and procedures. So this is where we come in, and that's the reason why we drill and drill and drill our students with these mathematical multiplication facts. Why do we have to keep practicing with long division? Why do we have to keep practicing multiplication, division, and addition and subtractions of fractions with unlike denominators? Why do we have to keep doing that? Because it's through fluency and through speed and accuracy, they save so much more time so they can focus more on the bigger problem at hand. Sometimes the word problems that the students will face is not necessarily just looking for what's the answer after you've multiplied two fractions. That's normally not necessarily what's being looked for or the final answer. Sometimes they will have to evaluate the situation in the end or use the answer they got after multiplying the fractions to solve a bigger problem. So this would really help our students if we can practice with them and make them more fluent in the procedures and the calculations that we have to do in mathematics. When students have the ability to use math flexibly, they are able to apply their knowledge to solve problems. One of the biggest shift between the previous GED test and the new GED test, the 2014 GED test, is that there are now a lot more word problems and real-world situations that our students face with. And now we are scrambling for the last-minute resources of where to get these wealth of word problems so we can start practicing them with their students. If we apply this new curriculum, College and Career Readiness Standards, for ABE Mathematics for our students in the ABE level, you would find that students are more able to use the math concepts that they've learned once they enter into GED, once they enter into college, once they enter into career, technical, vocational field. They're able to apply the mathematics more flexibly to the situation and to the field. What are the implications of rigor in our classroom? Rigor in lesson relates to a depth at which the major work of each level should be addressed. So again, just like I said, these three major components, they do not always have to be present in a particular lesson. Again, sometimes maybe today we'll just focus on first conceptual understanding of that. And then now that my students have fully understood the math concept behind, let's take, for example, the concept of area. Now that they know and understand where those areas come from, then we can start practicing fluency. So we give them different figures of, let's say, triangles and different types of triangles. We can give them right triangle, isosceles triangles, scalene right triangle, and then start practicing with them and start gaining speed and fluency. And then after that, we can do the application portion of that and say, well, let's put the triangles that we just solved in a word problem, in a real-world situation, such as a roofing or such as a triangular shaped garden. What's also better is to flip-flop because it's not in a particular order. Conceptual understanding does not have to come before fluency, and fluency does not have to come before application. That's not there's no order to these components of rigor. Application can surely start at the beginning, and as you apply, you can unravel the different concepts within a particular real-world scenario. Or you can start off with fluency and just practicing with students, let's say, operations on integers, -1 plus -3, -3 times 2. You can give them a few problems like that, and it's just to get them used to the fluency, and then start moving into conceptual understanding. Start putting them into a number line and see how the integers behave on the number line when we start doing operations between them. I'm going to show that to you in a minute, and this will all make sense to you as I show you some of the tips and tricks that I have for you to show you in terms of technology and also how to teach these mathematical concepts to your students. All right, so you've heard me talk about the standards of mathematical practice at the beginning of this webinar. What are these mathematical standards of practice? If you are a GED teacher, you already should know about these. Okay, there's 5 laid out in the GED assessment guide for educators. But what I'm going to show you is a different numbering. You got numbers 1 through 8, mathematical practice. 1, 2, 3, 4, and through 8, and so on and so forth. What you're going to see is these are the same things that the GED, that is being implemented in the GED curriculum. It's just that they are worded a little differently, and there are some are separated from each other. So, but they all pertain to the same big ideas that students should be practicing in the mathematics classroom. First, students must be able to make sense of problems. So reading word problem, I must be able to understand that problem, illustrate that problem, maybe write an equation about that problem. You know, it depends on what is being asked. And if they do not know how to do that, they must show perseverance. At least they try. What is the first step? What do I know and what is given in a word problem? Mathematical practice 2, reason abstractly and quantitatively. So this particular mathematical practice, what we have to do in order to implement this is to train our students to explain their work. To explain, some students can do multiplication of fractions on top of their heads, just like that. But if you ask them how they got it, they won't know. Or they do not have the mathematical language to explain it. And this is what this mathematical practice means, that we have to constantly practice with our students to express themselves and explain themselves in mathematics. Because sometimes a word problem or sometimes a question on the GED or the TABE test is not really interested about the final answer. Sometimes they're asking for a procedure. What should you do next? That type of thing, if we don't practice enough in this mathematical practice number 2, students will be caught off guard they encounter these problems. Mathematical practice 3 is construct viable arguments and critique the reasoning of others. This is when we need to practice with our students to look at somebody else's work and try to analyze their solution if it makes sense, if the solution is mathematically sound, or how can the solution be shortened, or how can a solution be lengthened or expanded. Those are the types of things that we need to train our students to look at, because this, and by the way, this is a very high level of critical thinking process already that we're practicing with our students. If they can do that, they can do a lot of things. So that means that practicing with their students and looking and just allowing students to explain their work, show their work on the board, or show them under the Elmo, or and show them under the Elmo, and have another student comment on that work. That should be a good start for practicing this this standard. Mathematical practice 4 is modeling with mathematics. So what this calls for is that if we're given a situation, can we write an equation? If we're given a situation, can we draw the problem and show? Or can we draw, let's say, if we're given a situation as to a rectangular garden with dimensions so and so, can the student draw that or model the mathematics behind that problem? And then after that, it maybe probably solve the perimeter or solve the area of that particular garden. Now, other things, when you go into statistics, modeling becomes a little bit more different. Statistics now, you're now going to have to look at the distribution of a particular data, and see if it is if there is a trend, and if there is a trend, let's say if data is. Let's take, for example, I want to talk about a real-world situation. Let's take, for example, gas prices between, the average gas prices between 2011 and 2014. And during that time, you will notice a sharp increase in gas prices. So, therefore, can we model that increase with an equation? Can we find an equation of a line that would best describe that increase in gas price? Mathematical practice number 5, use appropriate tools strategically. When you come into the face-to-face, or when you attend our face-to-face workshop, this is what we are going to drill upon, is the use of appropriate mathematical tools. Students, the reason why they don't understand fractions is because they don't see fractions. They don't see how fractions is represented in their daily lives. They don't see the relevance between learning how to multiply a fraction, because they rarely will multiply fractions in their daily lives. But more often than not, they really do all of these operations unknowingly, and we need to teach the students, give them the tools to so that they can show, or so that we can show to them these processes. We're going to, when you attend our workshop, we're going to talk about geoboards and colored counters and algebra tiles and number lines. We're going to look at all of those tools so that the students can appropriately use them to explain the mathematics behind their thinking. Mathematical practice number 6 is attending to precision. So this one comes in as, do we round? Do we simplify? Do we estimate a particular answer? And if we do, to what point? Up to what degree? Students must be able to make that determination when working with word problems. Mathematical practice number 7, look for and make use of structure. This is when students are supposed to be able to draw out the pattern in a particular situation. A lot of this, is being developed when you go into probability, looking for patterns and predicting what should be next, and or what are the chances of. These are this really forces the student to find a structure or look for patterns in a particular situation, and to make a more accurate prediction of what's going to happen next. Mathematical practice number 8 is looking for and expressing regularity in repeated reasoning. So just like I told you, if you look into the mathematical practices that are being introduced in the GED level, it's the same. MP7 and MP8 are put together because they almost, to me, mean the same thing. This is, can students see out regularity in a particular one? That can students understand that multiplication and repeated addition could be expressed the same? You know, so those are the types of things that that they're talking about in terms of mathematical practice number 8. Okay, so why? Why do we have to practice these with our students? Why do we have to do this in our classrooms? Well, based on research, the standards of mathematical practice rest on the processes and proficiencies with established significance in mathematics education. This is based out of the National Council of Teachers of Mathematics, NCTM, the developers of our Illuminations website. According to them, these are the things that students should be always practicing inside the classroom. You may not be practicing all of them at the same time, but at least these are the things that show if it's done in the classroom more frequently, shows greater success on the part of the students. When the standards of mathematical practices are connected to content, deeper understanding can occur, enabling students to extend them to new situations. So again, we're going back to this ACT National Curriculum Survey. Their initial comment previously that we talked about really aligns with this one. Remember when we talked about coherence? The coherence part in the coherent shift in your standards work side by side with these mathematical practices to help the students gain a deeper understanding of your content. And therefore, if they understand the content, they understand the skill. Why did they have to do the skill? They understand the concepts behind the skill, then they can extend them to new situations. So therefore, we don't have to really teach students all the different types of GED problems or TABE test problems that they're going to be encountering. Students will be exploring them themselves because they have such strong foundations because of the coherent curriculum that we have, and also because of the standards of mathematical practice that we implement in our classroom. Attention to the standards of mathematical practice shifts the emphasis from just how to get the answer to also learning how to learn. So this is really digs to the core of mathematics. How did I learn mathematics? Sometimes I think back when I was in school, how did I survive calculus? Or how did I even survive geometry when I was in high school? I hate that subject. I didn't really like it at first because I didn't like memorizing formulas. I'm not really good at that. But when you apply the standards of mathematical practices, you will really what you're really actually doing is you're allowing your students to learn how to learn. Is that there is an importance to memorizing certain formulas, because sometimes you will use their formulas to reason, to prove something is true, to prove something is false. Or if I knew the formula, I could easily manipulate that formula to find a particular unknown. And if I have not been persistent enough, if I have not been fluent enough, I won't be successful in that practice when I'm asked to do so. What are the implications of the standards in your classroom? The standards of mathematical practices are applied across all levels. So therefore, the foundations level ABE teachers and the intermediate level ABE teachers and your advanced level ABE teachers are practicing the same sets of skills. So therefore, you're all helping each other move the student forward. Not all standards of mathematical practice are appropriate for every lesson. So that's another thing. You're not supposed to force a particular mathematical practice if it's not appropriate. And then lastly, students need opportunities to experience all of the standards for mathematical practice over the course of the unit or the level of study. So it may not be applicable for every lesson, but eventually as you cover, let's say for example the unit on geometry, let's say perimeter, or let's take for example a surface area. When we teach the surface area or the section of surface area, there must be some different mathematical practices embedded on the different days that we've taught that particular lesson. Now we go to the fun part. If you have attended the face-to-face workshop, you would already be familiar with these mathematical manipulatives. But if you haven't, I'm just going to give you a brief taste of what this is and how it will really, really help your students to understand the mathematics. There are a lot of websites out there that are for free that you can explore with your students. One of the things that I'm sharing in the face-to-face workshop is this Glencoe site, which shows you different manipulatives. It has algebra tiles. If you know how to use the algebra tiles, you can use that with your students. They also have color tiles that you can use for elapsed time. You can practice them with the clock. You know, that's another manipulative that you can use with your students. A lot of students don't know how to count time now because everything is digital. We also have geometric solids if you wanted to show the different solids. So this is a really fun and really useful manipulative that you can show your students. Let's say, for example, or you can use in your classroom. For example, showing them these three things and then asking your student, what does that mean? What does that look like to you? And then starting the discussion from them. Some of your students will say, well, that looks like +1. Okay, for some of your advanced students, they could already say that. But let's say some of your other students may say, well, I see 2 yellow and 1 red circle. That's okay. That could be represented as 2 yellow plus 1 red. But that's also, some students may even say, okay, well, what if I assign a positive sign on the yellows just to make it shorter, and then a negative sign on the red? So we can say, okay, well, that looks like 2 plus -1. And that can also look like 2 minus 1, or -1 plus 2. So all of these things are really valid representations of what they see, as long as and you start them off with that, and all of your, even your students that are not really typically jumping into the discussion because they don't know math, and there's always that person that knows what to do, that raises the answer first. Even those students that do not have the essential mathematics background to participate in the discussion, they will be able to jump into this type of discussion and bring in what they think they see. Because you're not really, to them, it doesn't seem like you're asking a mathematical question if you tell them, describe what you see, you know. So that's a really fun manipulative. When you go into our face-to-face workshop, we're going to talk about that. We talked about the number line and talking to the students as to, okay, well, find out where negative, let's look at that. And can we find out where this value, oh, I can't write. Let me see. Apparently my writing tool is not working in here. Oh, I see that. What if we have a square root of 2? Now, or let's say pi. Okay, where is that? Where does those two numbers fall in this number line? You know, that's a good discussion that you can have with your students. You know, you can start by comparing. Let's take this square root of 2, for example. Well, square root of 2 should be between square root of 1 and the square root of 4. Okay, should be between there. Well, we can assign it with that symbol just to show that the square root of 2 would be less than the square root of 4, and then it would be greater than the square root of 1. But what is the square root of 1? And what is the square root of 4? So it's really between these two numbers. So students, but then you raise the next question. Is it closer to 1 or is it closer to 2? Is it right smack in between? So those are really very good discussions that you can be having with your students when you do these activities. And when you implement these mathematical manipulatives at your fingertips, you'll find it easy to do that informal discussion with your students, not really a threatening environment as to where it is. Let's take, for example, they always associate it approximately equal to 3.14. Okay, I always train my students to use that approximately equal to symbol. But if you look at that, where does that really fall in this grand scheme of the number line? Now in here, as you go through here, you're not only teaching them the number system, you're also teaching them how to compare numbers with each other. So you're teaching a lot of things here. And then the fact that you're showing it in a number line, you're already touching and teaching them the geometry behind this such abstract concept of irrational numbers. Let's talk about the GeoBoard for a minute. These are, this is another tool that I'd like to share with you. Again, if you want the websites and how to get to these, you just this is recorded, so you can always go back and pause the video, and you can see the website on the upper left corner of the screen, so you can always do that. So in the GeoBoard, we always use that as a visual tool for our students. But let's take, for example, this irregular shape that they don't know. Let's start finding the area of that shape. So in this tool, we can always color it, and that's it. That's what we're looking for. We're looking for the area. So coloring, it allows me to color and uncolor it. And then, well, I'll have students, some of my students will divide it into these shapes. This shape and that shape. And then you have already your third shape right here. So now my students will able to be easily divided the shape more efficiently. Some of my students can't draw, so they would rather put it in a GeoBoard. And then from that GeoBoard representation, they can figure out the area of the composite shape. Algebra Tiles, there's a web app out there developed by the National Council of Teachers of Mathematics. There's a web app out there that's available that you can use to practice with your students how to model equations using the algebra tiles. And again, when you come to our face-to-face workshop, we go in detail in explaining how to use these manipulatives. Let's just take, for example, this representation. I'm asked to build a model. I'm going to do a 2. So this is my representation of 2 on the left side, minus 3x. That minus sign then, shows that this second quantity right here is a negative. So I'm going to put negative 3 of those x's in here. And then on the right side, I put in a positive 2. So I'm going to flip back to my positive colors. And then I see another minus 2x, so that tells me that this second quantity right here should be a negative. So right there. Now, and then you can check. And it will beep, and it will ask you to solve the problem. So I also have a grab and go video. If you go into the IPDAY website, this is the IPDAY website right here. I pulled it up for you. And you go into ABE and you go into videos, you will be able to find where this is. I have here a tutorial or somewhat of a grab-and-go video that shows you how to use the Algebra Tile web app. So you can just click on it and it will lead you to the video. Unfortunately, it's being blocked, by my school district right now because I'm using my own personal device. But if I did use my computer, my school computer, this will load up properly. There you go. I've shown you different virtual manipulatives, and when you come to our face-to-face workshops, you will be provided with these manipulatives, your own set of physical manipulatives that you can use in your classroom. So I really suggest that you come. The next time we're, and just so you know, if you wanted to know, the next workshops are happening at at West Palm Beach or West Palm Beach, Florida, at the the Fulton Holland Education Services Center, and that's happening on November 9th and 10th. And we're doing it in the evenings, so it's even better because for the teachers that teach during the day and cannot come to our daytime workshop, you can attend to this one. And again, it's in West Palm Beach, Florida, November 9th and 10th. And you can look at the IPDAY calendar of events to look and look for the CRADES Mathematics Workshop. We're also coming to Indian River State College main campus on November 13. And the last for this year, 2015, would be in Orlando, which is on December 7th at the Orlando Technical Campus. So again, I just wanted to share you with that, and just if you have not attended any one of our workshops, we've received tremendous feedback from the field. We've even saw teachers that have started implementing these strategies in their classroom and have started crunching through the curriculum using these suggestions. So again, go into the event calendar and look for CRADES Mathematics Workshop. That's where you're going to be able to find that. And this is an example. If you click on October, it will show you all of the workshops in October and more details to get the agenda, or click on register for the event if you want to go ahead and register immediately. And that's pretty much it, what I have for now. I wanted to spend the last 4 minutes to entertain some questions. If you have some questions out there, feel free to raise your hand and type in your questions. Let's see what I've got here. Oh. Okay, so I've got some questions here pertaining to technical difficulty. Yes, I have a question on the PowerPoint. You will have a copy of this PowerPoint presentation. It is going to be loaded immediately. If it's not already loaded, when you log into this webinar, it should be on that page. I see that one question there. There are some questions on the technicality. Is there the ABE curriculum? Yes, that's what I wanted to show you right now. So let me show you the ABE curriculum that I'm talking about. This is the ABE curriculum right here. And this is just a page of it, the curriculum. So the front page is this. So that just so you know, if you want to recognize what this is, so it tells you the new standards. It was released July of 2015. Remember when we talked about those 10 domains? This is where you're going to find the 10 domains that we just talked about. All of those 10, and see how they're distributed across different national reporting system levels. If you look at it at an NRS level, for majority of your concepts already at the bottom, you're focusing on domain 6, 7, 8, 9, and 10, because those are the higher levels of mathematics that are really important foundations for your mathematics. And then when you look into the actual curriculum, this is what you're going to see. There's 2 levels. There's 2 columns, one for the previous level and one for the level itself. And then it gives you the stem of the major stem. So let me go ahead and highlight that. This is the major stem right here. And then you also have these subdomains right here. What are you supposed to teach if you have to break it down? Let's take, for example, another one. I found one that's really good for purposes of discussion in this workshop. Right here. If you look in here in this particular standard, solve mathematical and real-life problems using numerical and algebraic expressions and equations. If you look in here, I wanted to just draw your attention to here. Even though this one will focus on algebraic thinking and writing equations, you see how whole numbers, fractions, and decimals are still being emphasized in this particular standard. So you see how the coherence plays out, that you have to spiral back. You are forced to spiral again over the concept that you've taught before, because in this particular situation, multi-step mathematical real-life problems will be presented with whole numbers, fractions, and decimals. So therefore, students have to be fluent in these skills in order to be able to really tackle this. Let's look at this. Look at this one equation right here. Px plus q equals r. This represents our two-step equations. It means in order for us to solve for x, there is two steps. And in the face-to-face work, different ways to incorporate the algebra tiles to connect the algebra behind this and the geometry. So we're going to show you the connection between these two solving equations in this format using algebra tiles. So there you have it. Anyway, I think we are out of time. Again, I would like to thank everyone for spending your precious time sitting in and listening to this webinar. I hope I was able to answer all your questions. Feel free to email me or email IPDAY if you have any questions or if you have any problems accessing the materials associated with this webinar. And also at the same time, just so you know that this webinar is being recorded, so you can always play it back. And I know I kind of speak a little bit fast this time because I've got so much to cover, but don't worry, you can always rewind and fast forward, or play back this webinar. Again, I'd like to thank you for your great participation this afternoon, and hopefully you were able to gain a lot of information, and you'll be able to use some of the strategies and tips that you got from this webinar in your classroom. And again, feel free to join our workshops, our face-to-face workshops that are coming to your nearest areas. Have a wonderful day.